This live show for us for Olympus is the first time that we organize something like this, and we are really excited. We managed to get some live samples, and what we want to show you today is what we call a IKSI. A stands for Spindle Location ИКСИ. So what we are going to do is to visualize the spindle with a new system by Olympus that allows a real-time visualization of the spindle. First of all, let me introduce Maria from Embryo Tools. Embryo Tools here in Barcelona. We are partners, we cooperate. So thanks to them, we have a skilled embryologist, and we also have very nice oocytes that hopefully will show up the spindles in a decent way. So we are playing here with a little bit of risk, but we will try to manage. So we were talking about a spindle location or a spindle visualization. As you know better than me because you are a biologist, so you have been working in this field for many years. Visualizing the spindle has different benefits. First of all, it's a way to measure the degree of maturity of an oocyte. So on those oocytes where the spindle is present, you know that it's the right time to do the ИКСИ. It allows also to assess the quality of the oocyte, of the embryo afterwards, because it's described, there are several publications that describe that there's a relationship between the quality of the spindle and the quality of the oocyte. I'm looking to some embryologists that can confirm this, that I'm not saying nothing wrong. So we are okay until now, yeah, okay, fantastic. And the third one, and that's what IKSI stands for, is to locate the spindle before doing the ИКСИ. So to making sure that the spindle is not damaged when you manipulate the oocyte. So these are the three main benefits of these techniques. So here what we have is an Olympus microscope. As you know, Olympus manufacturer of microscopes. We have all the full range of microscopy for AVF, inverted, stereos, and microscopy for embryology. But in this case, we have here an inverted microscope where we have something that is a little bit special. Here is the combination, some kind of automation on the observation. So what we do is we combine an automated condenser with an automated nose piece, and this allows us to change from different observation methods very easily, just with the push of a button. So just with one button, we switch from relief contrast, from Hoffman observation, so from normal contrast that you are used to work with, up to polarization. And this is done in a very easy way. So if you have been working with polarization in the past, maybe you remember that it was somehow difficult to get an image. You need to go through a camera and through a software. In this case, it's pure optics, it's pure microscopy. So we have live image under the microscope. We don't need even a camera. We can see the spindles down on the microscope. Now here we have the two screens where you will be able to see the spindle. Polarization at the end is not very complex. It's not a very complex technique, but requires some kind of adjustment of the microscope. So doing like this, automating these processes, we ensure that for the embryologist it's very, very, very easy to change from one observation method to the other. So, sorry, I've been talking for maybe too long. So you want to see the samples, no, right? So let's hope that we have a nice image. So let's go to live. Okay. And here we have already the oocytes. Now we are at 4 times magnification. So here you can already, with the 4 times lens, see some of the spindles on those oocytes. Of course, we are using mouse oocytes. So with the 4 times lens, you already can get an idea about where the spindle can be located. Of course, it's not easy to rotate the embryo at 4 times, so the normal procedure on a ИКСИ procedure will be starting at 4 times lenses, get the pipette, the sample in the area of work, get the pipettes well aligned, and from this magnification, then switch to Hoffman 20 times. no, like we have in the sample. So this is a normal Hoffman image. Maybe due to the camera you can see a little bit bluish, but under the microscope it's the normal image that you can see. And now we can switch to polarization at 20 times. And you can already see that we have the spindle located here. And in this case, we have the polar body in this just the opposite. And this is what is happening in a lot of cases. No? There's a percentage of cases where the spindle is not located directly under the polar body. And this seems to be even more frequent on those oocytes which are vitrified. No? When with the vitrification and thawing procedure, the vitrification seems that this is happening. So the next step will be locating the spindle in the right position. So Maria will explain you how we are handling.
Yes, as Ben explained, it's very easy to use this technology because you only need to press 3 or 4 buttons and then to know how to rotate an oocyte. And for doing that, you can combine 2 movements. The first one consists of rotating the oocyte in the x-axis. Okay? Just by going up and down with your ИКСИ pipette, and you have to rotate the oocyte until you have the spindle in the right focal point. Once you have it, you can start with the second type of movement that consists in rotating the oocyte like a clock. Okay? And for doing that, you have to be very well focused and have the zona pellucida and the ИКСИ pipette in the same plane. And just touch a little bit the zona.
As you can see, there are some changes on the color of the spindle depending on the orientation of the oocyte. This is due because polarization is a technique that shows the light. So when you rotate the oocyte, this affects on the way you are imaging the spindle. But at the end, we are taking a look at exactly the same structure. No? Before we saw it here in this, let's say, darker image. Then we have it here with more bluish. And if we continue rotating this sample, at the end we will have another time this more bluish sample. It's no magic, it's no contrast, it's not a digital image effect. It's just the fact of how the oocyte is rotated, respect the orientation of the light on the microscope. No? So in this case, the next step will be just switch back to 20 times Hawk relief contrast image, and now it's the right moment to do the ИКСИ. So as you can see, the process itself is very easy, it's very quick, and everything is done on real time. No, even some cases that can be thought to make a biopsy of the spindle. All the movements are right down under the microscope, so are very fluid, are very easy to do. With this procedure of ИКСИ, just making a short summary. The first step will be get the image at 4 times, so you locate the sample and you locate also the pipettes, align the pipettes in the right way so you can work. From this, switch to 20-time lens, maybe directly to polarization. See where the spindle is located, rotate the oocyte as Marie explained. So in these 2 axes, on the x-axis, rotate the spindle until you have the spindle on your focal plane, and then rotate it clockwise or counterclockwise, depending on the location, so you can make sure that when you do the ИКСИ, you are not affecting the pipeette. Okay, that's it. This is what we wanted to show to you. Thank you very much for your attention, and of course, if you have any question, if you have any doubt, and if you want to see the samples, you are more than welcome. Thank you.